All right, let's dive into one of the biggest questions out there. We're talking about dark matter, the invisible stuff that, it turns out, is the true architect of our entire universe.
And this quote, wow, it just hits you, right? It perfectly captures the whole mystery. Think about it. That incredible swirling galaxy we see in pictures, our home, it's just the shiny stuff. It's like seeing the foam on a wave but missing the entire ocean underneath. What you see is not what you get. So where do you even start with a mystery like this? How do you realize you're missing, well, most of the universe? It all began with what you could call a cosmic crime scene, and the main clue was something moving impossibly fast.
Okay, so picture this. It's the 1970s, and the incredible astronomer Vera Rubin is clocking the speed of stars in distant galaxies. Now, basic physics, the same rules that govern our solar system, says that the stars on the outskirts should be moving way slower than the ones in the middle, right? Just like Pluto creeps along compared to Mercury. But that's not what she found at all. The stars on the very, very edge were zipping around just as fast as the stars near the galactic core. The whole thing should have just flown apart. The only way it could possibly hold together is if there was a ton of extra gravity coming from some massive, invisible stuff.
And this graph, this is the evidence right here. It lays out the problem so clearly. See that line sloping down? That's what the speed should look like, based on all the visible stuff, the stars, the gas, everything we can see. But that flat line, that is what we actually see every single time. That flat curve was the first bombshell, the first piece of hard evidence that the universe had a huge secret. Now look, a discovery like that is absolutely massive. But if you're going to claim that 85% of the universe is missing, you better bring more than one piece of evidence to the table. You need an airtight case. And that's exactly what scientists started to build, with 3 totally separate lines of proof. Get ready, because this is the smoking gun. This is the bullet cluster, and it's as close as we've ever come to taking a direct picture of dark matter. What you're looking at is a cosmic car crash, 2 massive galaxy clusters that have passed through each other. All the normal matter, the hot gas you see in pink, collided and got stuck right in the middle. But the gravity, which is where most of the mass is, shown in blue, it sailed right on through without even slowing down. This shows without a doubt that the stuff with all the gravity is physically separate from the stuff we can see. Game changer.
All right, for our second piece of evidence, we have to travel all the way back to the dawn of time, to the afterglow of the Big Bang. This is like the universe's baby picture. And if you look closely, it's not perfectly smooth. Those tiny temperature differences are basically fossils from an ancient tug-of-war. You had dark matter's gravity pulling everything in, trying to make clumps, and you had normal matter, which was super hot and under a lot of pressure, pushing everything out. This cosmic battle created massive sound waves that left a permanent echo in this ancient light.
And here's the kicker. This isn't just a cool story. It's math. To get the exact pattern of ripples that we see in that baby picture of the universe, you need a very specific recipe. And that recipe calls for about 5 times more dark matter than normal matter. It's not a ballpark estimate. It's a precise measurement, basically written into the cosmic code from day one.
Okay, so the evidence is overwhelming. We've established that this invisible ghost is real and it's everywhere. The next logical question is, what is it? And just like in any investigation, the first step is to rule out the usual suspects.
So you might be thinking, maybe it's just normal stuff we can't see, like fate stars, lonely black holes, or just big clouds of dust. Well, scientists checked, and the answer is a hard no. Our models of the Big Bang tell us exactly how much normal proton and neutron matter should exist, and we've basically found it all. They did huge surveys for things called machos, big dark objects, and found next to nothing. And it can't be something speedy like a neutrino, because those guys move too fast. They would have blurred out the tiny seeds that eventually grew into galaxies. So whatever this stuff is, it's something totally new.
So if it's not normal matter, what is it? Well, that's where we get to the prime suspects from the world of particle physics. For a long time, the leading candidate was the WIMP. Think of it like a gas of invisible heavy marbles. They don't interact with us, and billions are supposedly streaming through your body right now. But a newer, really interesting idea is the Axion. It's the total opposite, super light. Instead of a gas of particles, it would be more like a cosmic jello that fills all of space, just sort of humming in the background.
But this is where the story takes a huge turn. Because dark matter isn't just about missing mass or solving a puzzle about spinning galaxies. No, it's much bigger than that.
Dark matter is the master architect. It's the reason we're here, the reason anything is here. Think about the early universe. Regular matter was just this hot, chaotic soup. It was way too energetic and full of pressure to clump together. But dark matter, it doesn't feel pressure. It only feels gravity. So while everything else was bouncing around, the dark matter started to quietly clump together, forming these huge, invisible gravitational wells, or halos. These halos were like cosmic cradles. Their gravity was so powerful it pulled in all that hot gas, which then finally had a chance to cool down, condense, and ignite into the very first stars and galaxies. It's a simple chain of events. No dark matter means no halos. No halos means no galaxies. Period.
So this completely changes what a galaxy even is. You know that beautiful spiral image of the Milky Way we all have in our heads? That's not the galaxy. That's just the luminous froth, the bright stuff that sunk down into the middle. The real galaxy is the gigantic, invisible sphere of dark matter surrounding it all. A halo that's way, way bigger and way more massive than all the stars we can see.
And if we zoom out even further, it gets even more incredible. On the absolute largest scales, dark matter's gravity has sculpted all the matter in the universe into the largest structure we know of, the cosmic web. It's this vast, breathtakingly beautiful three-dimensional web that forms the fundamental skeleton of our universe.
And you can think of this web as having a few key parts. First, you've got the filaments. These are like the cosmic highways, long threads of matter and galaxies. Where those highways meet, you get the nodes. These are the bustling big cities, giant clusters of galaxies all crammed together. And then, in between all the action, you have the voids. These are the vast, dark, empty stretches of cosmic countryside.
So, just how important is all this? Well, we can actually run the experiment on a supercomputer. On one side, you simulate a universe with dark matter. And what do you get? A beautiful, complex cosmic web teeming with galaxies, basically the universe we live in. Then you run the same simulation but take the dark matter out. The result? Nothing. Just a thin, cold, boring soup of gas that never forms anything. It's a dark, lifeless universe. The conclusion is inescapable. We are here because dark matter is here.
This is why figuring out what dark matter is made of is one of the biggest, most urgent quests in all of science. It's basically a global manhunt for a missing particle, and physicists are coming at it from every possible angle. The strategy really boils down to three approaches. You can try to shake it, make it, or break it. Shaking it means building these huge, ultra-sensitive detectors deep underground, basically just waiting for a dark matter particle to wander by and bump into one of your atoms. Making it is what they do at the Large Hadron Collider, smashing particles together with so much energy that hopefully, dark matter particles pop into existence. And breaking it means pointing our telescopes at places where dark matter should be dense, looking for the telltale flashes of energy from when two dark matter particles smash into each other and annihilate.
So when you boil it all down, you end up right back here. Dark matter isn't just some curious little oddity in our cosmic models. It's the keystone. It's the silent, invisible architect that built the scaffolding for everything else. Without it, none of this, the stars, the planets, us, would exist.
And that leads us to this pretty humbling pie chart of reality. When you tally up everything in the cosmos, all the stuff we know, every star, every galaxy, every planet, every single atom in your body, all of it adds up to only about 5% of the total. The rest? Well, the rest is dark and mysterious.
Which really leaves you with one last, kind of mind-bending thought, doesn't it? For all of human history, we've looked up at the stars and thought, that's what the universe is. But now we know we're just living in the luminous froth, the tiny, visible part of a much larger, darker reality. It makes you wonder, if we miss this for so long, what other profound truths about our universe are still out there, hiding right in front of us?